Hello friends, welcome to my channel. Today we are going to design a circular microstrip antenna for 5G millimeter wave communication systems. But before I start today's design, I would like to tell you that the dimension we are going to use have already been calculated using the standard formulas that you may find in books or in the literature. Also, don't forget to subscribe to my channel because I will be uploading videos related to microstrip antenna design for many applications. So once you open your software, you need to launch the HFS, and by making sure that you are at the desktop option, and then you open your HFS like this, and yeah, you can see the coordinate system and the workspace appearing to your screen. And the next thing you need to do is what I usually like to do is to enlarge the coordinate system. You can see the coordinate system here by coming to view and choose coordinate system, make them large. And the first layer in the microstrip antenna is known as the ground plane. So that's why in this case I'm going to use a 3D dimensions to make the antenna resonate efficiently. So once you choose the box, just draw it, and you can see you have drawn a box. You can see the box appearing over here, and try to click on it, double click on it, and change its name. Let's say ground, ground. And here change its dimension, its property. It is a vacuum here, instead it's supposed to be a conductor. So that's why I'm using a copper as my conductor. You can also choose different material as your conductor. Alright, so you can see it has been changed from a vacuum to a copper. Just apply and click OK. So you just come to create the box and try to change the dimensions. Let it start at the origin, and choose LG as the length of the ground plane. In this case, it is 5 millimeter, and WG, which is 4 millimeter, and the height of the ground plane is the height of the copper, which are the standard values you can find in practice. So the height here is 0.035 millimeter. Just click OK, apply, and OK, try to fit it. You can see this represents your ground plane. So the next layer is going to be the same box, but this time it's going to be your substrate. Just draw it like this and repeat the process. Change the name into substrate, and from vacuum it needs to be a dielectric material. So in this case we are using the Rogers. Rogers is one of the most important material that people use in designing their antenna. The reason behind it is just because it has a low dielectric permittivity, constant relative permittivity, which is 2.2. Alright, just click OK, and yeah, now you can change its transparency from 0 to something like 70% or whatever value you would like. Alright, and you can also change the color into whatever color you like, and here you go. And you need to change its dimensions as well. Let it start at 0 on the X and Y axis, but let it start at HP, which is the height of the copper, on the Z axis. So it should have the same dimensions as the ground plane. In this case, it might be different in some cases. It depends on how you want your design to be. And also here we have the HFSS. It has its own height or thickness. We have the standard values like 1.575 that can be used in practice, alright, for Rogers. Okay, so this is your basic design. You can see the ground plane, you can see the substrate over here. So the next layer is the copper, the patch. Now we are choosing a cylinder in this case because it is a 3D component. Double click on it and name it patch. Alright, also it has to be a conductor, otherwise it's not going to radiate. That's why we are choosing a copper. You can also choose different material as you like. we are having all right, so this is it, and try to center the patch. Double click on it, and on the x-axis is going to be something like a plus rp. Rp is the radius of the patch. Now on the y-axis is going to be the width of the ground plane divided by 2. Yeah, that's going to make it centered. Now on the z-axis is going to be HP plus HS. You can see the A is just a random value that I'm choosing to make it centered. Now RP is the radius of the patch, 1.6 in this case. Now the radius of the patch and the height of the copper, so it is just HP as we have assigned the variables. So you can see your design has already been centered, right? So if you look at here, maybe we have given the wrong values for A. Let's try to go back and see. So we are trying to verify the values that we have given to to the variables. You just come to HFS design properties, and you can see instead of giving 0.3, I gave it 3. That's why it did not it was not centered at where we want it to be. So let me just change it to 0.3. You can see it's gonna, you can see now the patch has been centered. All right, so the next layer is known as the feed line. All right, so in this case I'm going to choose also a box. All right, because the boxes are 3D object. Right, so you can see the box here. It need to be a conductor as well. Let me just try to change its properties. It's going to be the feed line here, feed line, and choose the copper, and I think that's okay. And you just try to change the dimensions the way you did for all the rest. So it in the y-axis, in the x-axis, it should start at it should start at a divided by 2 plus 2 rp. All right, now on the y-axis we are going to choose wg divided by 2 minus wf. Wf represent the width of the feed line divided by 2 also. Then we have HP plus HS. All right, so the width of the feed line is 0.75 millimeter, and x-axis we have the length of the feed, which in this case is just 1.65 millimeter, and we have the width of the feed line, and we have HP, which is the height of the copper. All right, you can see your design is just wonderful. Now we can try to unite these two, the substrate, the feed line and the patch. So to do that, you need to click on the control button, press on it and hold it, then click on your patch, and you see, and click on the feed line. You can see they have been selected. So there are two options you can do. You can either come to here, modeler, choose your Boolean function. You can see the unite option. Click on it. You can see they have been united. So the next thing you need to do is to bring your port or the source of your antenna. So before you do that, you need to change the the orientation of the coordinate system. Instead of XY, you need to select YZ. Once you have done that, you need to draw a rectangle here. Here I'm not using the box. Otherwise, if you want, you can also choose the box. All right, depend on your choice. But for me, I'm using a rectangle in this case to excite my antenna. Just draw it like this, and here you go. Now you can come to the rectangle, change it as your port. All right, and You are okay, and try to change the dimensions. You can start on the y-axis. It's supposed to start at LG as on the x-axis, and now on the y-axis you can start WG divided by 2 minus W minus WF also divided by 2. Now on the z-axis supposed to be HP plus HS. Now you have your, on the y-axis supposed to be WF, and on the z-axis you can put minus and HP plus HS. Alright, so you can see this is your, now you can see your port here. So the next thing you need to assign it, to assign it you need to select the excitation, right click on it, and you can see assign excitation, then you choose the port as the lumped element in this case. Yeah, you can see you can choose the ground as your reference and object name. So the next thing in your design, you can see here the you just click try to open it. You'll see your analysis. This is where you set the frequencies. Right click on it, add solution setup, and you can choose advanced in this case. Here we are using the millimeter wave, which is the 28 gigahertz in this case, and choose your number of passes at 20, and you can click OK. Now they are asking you to choose the sweep here. I can decide to start from 20 to something like 45, right? And I'm gonna change the interpolation into fast and click OK. You can see this has been assigned. So the next step is your radiation box. So just right click on the workspace. You will see create an open region. You choose the frequencies to be the theoretical resonant frequency, which is 28, and you're okay. Then you try to fit it. You can see your radiation box. This is your radiation, this is your substrate, this is your patch. Alright, this is your ground plane. You can see all the elements are there. So the next step, you need to save your work before you start simulating. You can save it as project 2 in my case. Alright, so you need to try to see if there is no design error by clicking on simulation and validate. You can see validation check is correct, and try to analyze. It's gonna take some time when you start analyzing. Alright, now you can see it has been completed. Try to check and see. You can see normal completion on of the simulation. We just close it and try to plot the results. First of all, we are going to see the S11 parameter, which is the reflection coefficient of the antenna. Just come to results, right click on it, create terminal solution, and choose rectangular plot. Now you can see here we are talking about the S parameters here, and it is S11 because here we don't have many ports. It is just a single port antenna. We don't have an array or a MIMO antenna, so that's why you have S11, and you select DB. Make sure that you are on the sweep, not the last adaptive or adaptive passes. Select the sweep so that you can plot in all the frequencies from the 20 to 45 as you have selected. And in families you don't have any parametric analysis going on, so you don't need it. Just click on new reports. You will see your S parameters. So now you can see your S parameter here. Try to see the bandwidth that you have achieved. You can see here -10 to -10 criteria. You can see here. So you have two resonant frequencies in this case. You can see here the marker. Your antenna resonate at 29, and here it also resonate at 45.5. So if you want it to resonate at 28, you can just adjust the dimensions, such as the length, the radius of the patch, to see if the radiation, the resonant frequency can shift